Hey, welcome back. Today we're going to be talking about how much light is lost when going through a polarizer, or how do you solve Malus's law intensity of light problems. So maybe you're a physics or an AP physics student and you need to know something about the amount of light, the intensity of light that's able to pass through these polarizing films. And up until this point I've talked about the concepts for that and understanding how to think through these ideas, but I haven't really shown the math, so I'm going to start with a standard Malus's law problem and think through how to solve these things. You can see the equation is written right there. Notice it's got I for a variable, and that stands for the intensity of the light. We're not going to worry about units for this problem to begin with. There are a couple different units you can use for intensity, but let's make it easy to start with. And then notice that we have a cosine squared function. And I wrote down below, this is confusing for students, and I understand that it's confusing for students. That cosine squared function does not mean that we square the angle. It actually means that we run that cosine function twice. So cosine squared of theta is equal to cosine theta times cosine theta. So I'm going to show you the math for that too, and you can read the rest of the problem here. You can pause if you like, but I'm going to not read at you. I'm just going to go ahead and get started with this. So let's get to it. So we know this is our general equation here. And for this idea, this is going to be our I naught, and what we're left with after it goes through the first polarizer, we're going to label as I sub 1. And that's because you have your intensity of light that you're left after going through this first polarizer right here. Alright, so we're going to say, well, what's that intensity here? And we're assuming that we have 10. And this cosine squared theta, again, I want to be as clear as I possibly can here. So I'm going to say we're going to multiply times the cosine of, now theta in this case is going to be 20 degrees. And we do it again. We multiply by the cosine of 20 degrees again. And if we do our math correctly, you end up with 8.83. We'll use 3 sig figs for this. I'll go back and change this. We'll say 10.0 units, we'll call it. Alright, so 8.83 is going to be your intensity of light that you're left with after it passes through the first polarizing film. Alright, and we're just going to do the same thing essentially again, but just be careful with subscripts here because we want to talk about the second polarizing film. We're going to talk about it as if our initial intensity of light is going to be this I sub 1, and what we're left with is going to be I sub 2. So let's go ahead and set this up again and think to ourselves, what do we need to put in here? Do we need to put in cosine of 20 or cosine of 40? So what do you think? Alright, well, because we're talking about the change as we go from I1 to I2 right here, we're talking about a relative change between how it's oriented already. In other words, the electric field of the light is already offset at 20 degrees to begin with, and it's going to be offset at an additional 20 degrees over here to end up with. So we actually do need to use 20 degrees once again and multiply it by the cosine of 20 degrees once again. This I1 value though needs to be what we used over here, so let's think about what this is going to be, and you're going to end up with 7.79. Our units are arbitrary here. And lastly, we're going to say, alright, well, let's run this one more time. And so you know the drill. This I3 right here, this should be 7.79 times, effectively we're saying times the cosine of theta. And because it's a relative change from I2 to IF, actually I should change this to be consistent. This I wrote as IF right here, this will write as IF. Okay, so it's still a relative change, so we still need to use 20 degrees and multiply again by cosine of 20 degrees. So just be careful how you do this. So IF, in this case, you're going to end up with a value of 6.88. Actually, I did not round off to 3 sig figs. Every time I did that calculation, it just carried through my answers, so if you get a slightly different answer because you've been using 3 sig figs throughout, that's the explanation why. Alright, now, importantly, I want to talk through how to think about this. So I've talked in the past about, like, if you have any example of comparing example B to example A, like what we're left with, a way to do that mathematically would be to say B over A. So in this case, this follows the same pattern. We could follow up with a question that says something like, what is the intensity of the lights, so what is the final intensity of the lights as compared to the initial intensity of the light. And if you're going to do that mathematically, how do you do that? Well, you're going to say I final over I initial. And that will help you to conceptually, but also mathematically compare the differences. Well, our final is 6.88, and our initial was 10. Okay, so what does that even mean? Well, we end up with a final to initial value of 0.688. Again, what does that even mean? Well, what that means is 68.8% of the lights gets through, of the original lights gets through. And that's a really important idea too, to be able to take this and translate it into words and think about what does that even mean? 68.8%. So notice what I did right here to be able to understand this. This is just what we mean when we compare things with ratios. If we want to take our final and compare it to our initial, that's how you would go about doing it. You would have the final divided by the initial. In any case, hopefully this has been helpful. I've gone over an entire year of physics concepts and lessons. So if you're interested, please take a look. And I hope you all have a great day. Take care.